So in this video, we're going to take a look at how to quantify heat. Okay, so imagine when an object, so let's again go ahead and define our system out here. When the system either loses or gains heat, so let's say heat is coming into the system, so Q is coming into the system, what's going to happen is there's going to be a temperature change. When the system heats up, you're going to experience a temperature change. And what you can, the temperature change that is experienced is going to be directly proportional to the heat that's coming in. Okay, so we can say Q is directly proportional to delta T, the temperature change. That's the temperature change. Let's call that delta T. Okay, and then what's going to happen is if you remove the proportionality sign, then Q is going to be equal to capital C times delta T. So what's capital C? Capital C is known as the heat capacity of the system. Okay, heat capacity of the system, and heat capacity is an extrinsic extrinsic quantity. My bad. Extrinsic quantity. So if you rearrange this to solve for C, then C, let me just write it this way. So if you divide both sides by delta T, we get C is equal to Q over delta T, and the units of Q is joules, and the units of temperature is degrees Celsius. So the unit of heat capacity is equal to joules per degree Celsius. Okay, so it's important to know these units. Now, what we can do is, from heat capacity, we can kind of extrapolate from this and define another quantity called the specific heat capacity. The specific heat capacity is actually the heat capacity defined for every gram of the substance. Okay, so if we take the heat capacity C and we multiply it, so heat capacity, it's represented for a certain mass of the substance, times, that's called CS, the specific heat capacity. Okay, then we can just plug the delta T in as usual. Sorry, not here. So we have that is the heat capacity. So then if we take this entire thing and we plug it into this equation out here, then this becomes Q is equal to M, so the mass, times the specific heat capacity times the change in the temperature. Okay, so now if we rearrange this, then CS, the specific heat capacity, is equal to Q divided by mass times delta T. And the units of this would be equal to joule per gram per degree Celsius. Okay, so the specific heat capacity, these are like very standard numbers that are specific for different materials. So if you know the specific heat capacity, then you can change the mass, okay, and then you can measure the change in temperature and then back into the heat content. Okay, and again, there are many forms of this equation. Depending upon the kind of problem you're seeing, 3 of the variables might be given to you and you might have to solve for the 4th.